So as promised, today we're going to look at container runtime hardening, the first layer of defense that we built into Grate. Okay guys, so today we are going to learn about container runtime hardening, and we'll go through each of these items and in practice how this looks like with Podman. Of course, you can also do this on Docker without much. There is really not a big difference, I believe. And so first, let's take a look at the project. And this is what the project for Grate looks like. We were looking at the README file, okay? Most of the code is defined within this just file over here, and today we are going to focus on containers, so we'll be looking at our container files. Not all of these are relevant for today, mainly the base, probably the open code, the unbound, and the llama server. Radical is something that I'm working on. I want to test it, it's something else, but it will be sandbox as well. And then we've got our llama server, it is essentially an entry point. We've got our nono-wrapper, which takes care of profile composition in runtime. We've got our profile, which just shows you this cool thing when you enter the shell, and then you've got our run allowed, which is a dispatcher which lets you run multiple commands from a single container, but only those that are allowed to be run. This is not my best work, but it's enough to to filter it. And the other stuff will be covered on another video. So let's first take a look at the just file. And it's a regular file. We define tons of environment variables and some defaults for that we will be passing to the Podman containers. So the number of CPUs, memory limit, the PIDs limit, the network name, the subnet that we are going to use. Notice the 4.1 is for let's speak for AI, very cool. And then your workspace for this is specific for open code, and some models that we are going to use, the NFT file and all that. But as you can see, we also have the pinned versions for the images that we use. We never use this Rust image or Go image or llama server image as our main image. This is always copied over to a Wolfie base, okay? And so the main let's take a look, for instance, at build base. And for build base, as you can see, you can add some optionals here, and this will just check some args and install additional packages. And this is our main workflow. So we never pull the image. There is pull missing in here, I believe, but it wasn't working as well. It still needs to contact the server, but if you do it like this and it finds the image locally, it will not contact the server. So I instead pull the missing image separately, and then I'll use pull never here. Images will be built locally, and they will always be tagged with the latest tag. That's it, okay? No versioning. You should rebuild the image before you use it frequently, so there is no versioning. This will not be published. This will be adapted to your needs or to my needs. And then I send these build arguments to determine whether to install debug tools, which is like curl and stuff like nmap. It's debug tools. You shouldn't be installing them in an environment that you are working on, only if you are debugging the images, okay? Then cdev tools, let's say that I use this to test, to create some code to test the Seccomp profile if the syscalls were using, and so I added this. But I will probably add Go dev tools and Python dev tools and Rust dev tools in the future, okay? And so this is very simple. How you build it is not in the main thing here. The main thing here is this run recipe, which I call from everywhere pretty much. So there is a base recipe, and as you can see, this just runs the shell for you to test it out. And let's take a look at what actually happens here. So if you run, let's first build base. Let's do it with debug tools and with cdev tools, okay? And most of this stuff is already cached, but it shouldn't take long in your machine either. And so once this is built, you can run just base. And okay, we are on a shell. Who am I? I'm UID 8000. This is the Grate user, but because we don't have access to etc password, because we are running with nono, we aren't able, who I am isn't able to resolve that. So if you run ps, you'll see that we are running nono with the Grate profile and no diagnostics, and then we are just calling a nash login shell, which is the default shell for Wolfie, okay? And if you want to write here, you'll be able to, you know, touch example file here, and as you can see, you are able to write here. You are not able to rm/user, for instance, okay? User is still there. Okay, it's still there. Everything's still there. Of course, I cannot list it because nono is blocking all of this stuff. If I want to, you know, look into it, I can. I just run sudo podman exec it, and let's say I want to go into the base image. This is just to fetch the, you know, the container ID. And if I go into here now, I'll be able to, you know, list all the stuff, and as you can see, it's here because now I'm not running, I'm running with exec, so I'm not going through the entry point. Okay, that's just how it works. It's a good way to help you debug this stuff. Okay, and so I'm here. Let's try to ping 111 permission denied. Okay, and this is no denying and capabilities dropped denying these permissions. And so let's just take a look at what it's doing when you start it. So it first checks if it's got all the required utilities to build this and run this. It checks that the image exists, or it will build it. Actually, this is not correct because I changed this. So this is a bug. It shouldn't be underscore. And so it just ensures network. This will create the Podman network. Okay, then it just ensures DNS, and this will set up the container for unbound. So let's say I'm going to run it again. Let's just take a look at what containers will be running. So if I run Podman PS, you'll see that there is a container for unbound running here, and there is also the container for Grate base. If you run just open code, there will also be a container. Instead of Grate base, you'll get Grate open code, and you also will get a Llama server container, okay? Because it just starts that container by default. And so let's take a look at what is happening here. Let's continue. So it will start the unbound DNS server. It renders the unbound config because it will need to add stuff from the whitelist conf, okay? That's why it checks whitelist conf here. And then this is running unbound, I believe. Yep. And then it loads the firewall rules. So there are some variables that we set dynamically. If you go into the Grate projects, you can find these dynamic rules. These vars are set here, okay, and this will fetch the default Podman interface and subnet, which I might redefine for some reason. So if I take a look, let's just filter this, you'll find that there is a Podman interface that was created for this Podman network, and you can run Podman network ls. You'll see there is a Grate Podman network, and you can inspect Grate, and you'll find all this information about this network is here. The interface is Podman 1 and all that. Okay. And so next, once we load the firewall rules, we merge the default Podman Seccomp profile with our extra rules, and then we set those to be run with our custom container. In this case, it's Grate. Now let's take a look at all these arguments which we can find under this run thing here. Okay. So as you can see, run will take an image, an application workspace, and yes or no string, I believe, for or true or false for whether we want to run this with the GPU. Because when we run it with the GPU, we use the GPU's all flags, okay? But we do not use the UID mapping because it doesn't work for some reason with NVIDIA container toolkit, and so I don't know if there is some workaround, but I know there is a PR related to this. I mean, an issue related to this still open. So maybe that's something that can be fixed in the future, and I can just, you know, drop this and integrate it into the main run. Since we are looking at this, let me explain what this is doing. So as you can see here, sudo Podman will be run with sudo. And I cannot run it as rootless, otherwise I wouldn't have the Podman interface, the bridge interface, to implement my firewall rules. So I instead map the 8000 UID to my user's UID. Because I'm running as sudo, this will not be the UID for root, it will still be for my regular user, unless I used sudo in here, right? And this means this is the container, the starting UID inside the container. This is the starting UID for the host, and this is the number of UIDs that you want to implement. So this means that 8000 will map directly to my UID, and if this was 2, you know, my UID is 1001 would map to 8001. Okay, but I want this to map directly 1-to-1, and then I map from the root UID on my container to 30. I map it to the UID on the host from 30,000 onward, and I do this for 8,000 or 7,999 UIDs, so it doesn't collide with this. Okay, and this means that even if you are root and you are able to somehow escape the container, you will be running as UID 30,000 on the host, so you can't really do anything with this. Okay, and then let's take a look at the default Podman run. So I run this with RM, which means this is ephemeral. I don't have session support yet. I don't know if I will ever have it, but for now this is how it's working. It probably is not that hard to add it, but for now, this is all what I'm doing. I set the file system to read only. It means that everything within your container, except any bind mounts, are read only. Okay, and so because this is the case, I add a TMPFS to the Grate home. Ideally, this will have the same permissions as the Grate user, but I ended up creating it like this. So any directory that is within Grate will have the permissions that you added in build time, but specifically Grate will not. I think this is how this is working. I'm not sure if this is being created, but we can take a look. So let's take a look at this specifically, and let's inspect /Grate. So let's exec into the container so that we are not limited by any, the nono or anything else. Let's go into /Grate. You wouldn't be able to do this usually with nono available. And as you can see here, the /Grate directory has permissions, is ownership is root, and there is a set, a sticky bit here. So any user, it's like the TMP directory, okay? If any user creates something there, it will have its own permissions, its own ownership. But then any other stuff here will have permissions for Grate, okay, which is the user, the UID. So if you run it like this, you'll get UID 8000, because in here you'll have access to passwd, because we are not running this with nono in here, right? If I wanted to try this with nono, okay, I could do something like profile Grate, and then let's say I want to try to cat etc password, and it asks you to grant permissions to etc password, because it's not granted at all. So I'm going to suppress this, and you won't have access to it. If you want to, you can run hash and then try to cat etc password, and as you can see, permission denied. This is nono doing the work, this is Landlock doing the work, not container, right? And so as you can see, this is how the read-only NTMPFS is working. If we go in here and just try to, I don't know, touch, you can write in the workspace because it's a bind mount, but let's say something like this, it's a read-only file system. It's not even a matter of sudo, which I cannot do as well, but it's a read-only file system, okay? Then I mount the workspace for this specific application under /workspace, which is where you should always work. Your files will live here, and as you can see, there is a flag, this lowercase z, which is meant for SE Linux. If you are not running SE Linux, this is just ignored. If you don't do this, you won't have the required permissions to access the directory. And then we set the network to the Grate network, okay, and we are setting the DNS here, although if I'm not mistaken I can actually drop this option, because I'm not sure if I added this to the network directly. Let me check. Okay, I didn't for some reason. I think the reason for this is because if I don't add it this way, then etc_resolve.conf will not point to this DNS and will run into problems, okay? So if you go into here, you will have permissions to run resolve.conf, and as you can see, this is a custom IP. It's usually .1 for the avarc DNS, which is the default for Podman, and this will instead run through my own DNS. So if I do something like host hf.conf, and I only have access to host because I installed the debug tools, okay, otherwise I wouldn't, this will resolve. But if I try something like google.com, which is not on my whitelist, I believe, this is refused. You can also, run it with dig, and you'll see that it's using this DNS through UDP. And also this needs to be opened in the firewall, but we'll get to there in a future video. And so I drop all capabilities, and as you can see here, I didn't need to add any back, but if I need to do this, to add some capabilities back, for instance, for unbound, I need netbind service, set UID, set GID, and sysroot, change root, right? Because apparently unbound creates a kind of jail system for its own, which is good. So I will trust it with this. And so this is how you add capabilities back, and in this case I had to use a custom sudo podman run, which is very similar to the one that I use generically, but for this case I needed a different one. So let's go back to run. Okay, I'm going to mark this so I can jump back to it later. And so that's how you manage capabilities. Security OPT no new privileges means no set UID, I believe. And then in here we set our custom Seccomp profile. This is to filter your syscalls with Seccomp. We limit this to a given number of CPUs, memory, and PIDs. The extra arguments will be the UID map that we saw or the GPU. And then your image and your regular image arguments, which are passed from run, any arguments here. Once we are done, we unload the firewall, we stop DNS, and we remove the network. So it should be clean. Unless this crashes, then you can run just unload firewall rules, just stop DNS, etc. If for some reason the firewall rules remain up, they will only affect other containers that are running on the same interface for some reason in the future. Okay, so this might hit your other containers, but it shouldn't most of the times, and you can run just unload firewall rules, just stop DNS, just remove network. Okay, and that's pretty much how you harden your container through command line arguments. But now let's take a look how to do it through the image itself. Okay, so let's take a look at the container base image. So I needed to add nono, so that's why I've got the Rust image here just to install it. As you can see, I've got the version for nono pinned. I also use lock to make sure that the packages are the version specified with nono are the ones that are installed. But then I use a chain guard Wolfie base in here. I use, as you can see, the /Grate home, and I install JQ by default because this is usually needed for the nono-wrapper entry point, to extend. And this might be, a security flaw somehow, but every tool that you add, you must think about whether you really need it or not, whether you want it to be a potential security flaw or not. Then these are installation that are conditional on these build arguments. Okay, so this is just for debugging the images. I use Kitty, so I install kitty term info just so it doesn't annoy me. IP root will install the IP command. Bin tools will install host and dig commands. Curl, you know what curl is, right? To download stuff from HTTP. And strace helps you trace the system calls, which is helpful to debug seccomp policies. Then I've got my C compilation tools. I would have a similar block in here for Go tools or whatever. And then I copy my nono binary from the builder image. So nothing that you need to build Rust will be available here unless I create a block for this. And then I copy the profile, which just shows you the, that cool, welcome screen. Rather just do source, okay? And then I copy the nono-wrapper and the run allowed, which is used sometimes, not every time, but nono-wrapper is used every time. Then I add a group and a user, the home for the Grate user. I install a few basic utilities. Socat is installed because I needed to, redirect port 443 for TLS into port 8080 or something, or 80. I create some certificates to use when you need it, and by default, because I create this certificate authority on the base image, any other image will trust certificates created from this root certificate by default, which is useful. And then I create these directories for nono, so I can assign ownership to the nono user. I copy the Grate profile, the nono profiles for Grate, and I switch to the Grate user, and so everything in here, I validate those profiles, so if you are working on them and rebuilding, you have some sense of whether this is failing or not. And then I switch to Workday to workspace and I expose it as a volume. And our entry point will always be the nono-wrapper, but the command can change. It can be, I don't know, open code or something like that. So now let's take a look at nono-wrapper, okay, and see what it's doing exactly. As you can see, it just made it simpler to pass a few options like enable GPU or enable the CDev tools. And then it just wraps whatever command you want, okay? Checks if nono is available. We've got this try extend profile, which is how we extend the base profile with other profiles that we might need, for instance, the GPU profile or the CDev profile. And what are these profiles? So we've got our Grate JSON in here. I'll go into detail later in another video, but we've got our base profile and we extend it with other profiles. For instance, it might be the GPU profile, okay, and so it would be extended, or it might be the Grate CDev profile, okay. So let's go back to the base, and that's pretty much how you build the base. If you want to build another image, let's say the open code image, then we usually derive from localhost Grate base. We switch to root if we need to install some stuff, and then we switch back to the Grate user. We do it by name because we don't need to, you know, these arguments, these build args here. In here I'm just, you know, extending with the open code profile explicitly, and then this will be done at image build level, and then this will be other profiles can extend our Grate profile depending on the options here. So we are, for instance, adding CDev permissions to nono, and we are running our open code client, and that's it. So when we run just open code, let's create a temporary directory for code, and then let's just run open code. When we run this, it will start the Llama server automatically. It's running on another container, and okay, let's check this. So let's Podman PS. You'll see there is unbound as usual for DNS. There is the Grate Llama server. You can connect to it locally on port 8080 if you need to, but we are using port 8443 internally for with the certificate, and then you'll see the open code image running as well. So we can try stuff, let's say check if you have right permissions, and I don't know if this will work because my model is very small, but check if you have right permissions to /opt by creating an empty file. Do nothing else because it likes to do more stuff for some reason. Okay, let's see what it does. I'm not very experienced with this. I'm just learning because I was extremely paranoid about security, so I never really ran this comfortably. Okay, let's see if it can write. It shouldn't be able to write, but if it's able to write, you know, I have to tune something in the permissions. So the operation failed, and as you can see, let's say ping 111. Let's see if it's able to do that. If it's going to try to ping, it should fail immediately due to nono. Then it also fails due to capabilities being dropped on Podman. It also fails because of the firewall. You know, there are many layers to this. And so this is how you do a container runtime hardening. Okay, so going back to our README, this is how you do container runtime hardening. with privilege isolation, so drop capabilities, file system isolation, read-only TMPFS, privilege escalation prevention, so it's the security OPT, no new privileges, resource isolation, this limits CPU, memory, number of processes, identity isolation, this is the UID and GID maps that you saw. Network isolation means that we are running a separate network for Grate. Version pinning, our images all use SHA 256 hashes to be pinned, right? And hardened based image as a default, we use Wolfie. And that's how you do container time hardening. And that's how we do container runtime hardening at every front that I could think of. You know, use a more secure base image. That's, you know, to lower the CV number. That's like the basic hardening that you can do, but you can also do a lot more just with command line arguments for Podman or Docker. Set your file system to read only, run it with another user, change the UID mappings so that it maps to UIDs and GIDs that do not exist on the host, and so they can do nothing or close to nothing, you know. And so hopefully this was informational for you, and it will help you make it easier, you know, to contain your containers properly in your everyday operations, you know, harden it, because we are living in a time where you know, supply chain attacks happen almost every week, and so security is definitely a must. It's just not a nice to have anymore, it's an absolute must. And so hopefully my videos can help you get there more easily, because nothing replaces understanding your system, you know. So keep building your system engineering skills, and I'll see you next time.